as well. And yeah, my name is Jerry Ola. I'm one of the product managers here at Akahau. If you've joined a previous webinar, welcome back. And if this is your first time, thank you for joining. We hope you find this webinar informative and insightful. Before we get started, a couple housekeeping items. You're going to be automatically entered here in a muted mode here, listen only, if you will. And yeah, if you want to kind of interact with us throughout the session, we've got the Q&A panel there. You can submit your questions, and we'll make sure we look through those and answer those throughout the session, as well as save some time at the end to do a Q&A session. But we also do have a chat dialogue box there that I'll be kind of monitoring if you want to kind of chime in on some of these topics as our presenters going through there. But yeah, today's webinar topic is going to be on understanding the intricacies of hospitality Wi-Fi design. We brought in our industry expert here on the topic, Jason Hintersteiner. He's a director of business development at LegalWave. And yeah, joins us we've had him on previous webinars and really knocked it out of the park. So we thought it'd be great to have Jason on again to discuss this very important subject and, very, relevant topic, I would say, in today's industry. Hospitality is very front of mind. So yeah, without me chatting any further here, let's go ahead and get started. Turning things over to you, Jason.
Yep. Hello, Jerry, and hello, everybody, and welcome to today's webinar on hospitality Wi-Fi design. I'm going to start a little bit about me. I've been doing hospitality Wi-Fi for over 10 years now. I've been involved in several designs, deployments, and inheriting other people's networks and troubleshooting in the hospitality space over the last 10 years. And I've done this both from the service provider side as well as from the AP manufacturing side during my career. So I understand hospitality Wi-Fi from both the kind of the vendor perspective as well as from the implementation and integrator perspective. I'm also a frequent traveler because my current role at LegalWave, I'm traveling around a lot to drum up business for LegalWave. So that means I'm a frequent guest in hotels, and that means that I am a frequent user of hotel Wi-Fi. So I have to endure it both as a user as well as a network administrator. So, it gives me an interesting perspective on hospitality Wi-Fi because not only do I have to make it work, but I also have to be one of its users. As Jerry mentioned, I'm the Director of Business Development at LegalWave Networks in Canton, Georgia, and our APs readily support hospitality Wi-Fi and are used in many different hospitality Wi-Fis. I'm only going to use one Shakespeare quote today that's modified. It's a quote about hospitality from Much Ado About Nothing. Basically, it's right. The guys come, they visit Leonardo to stay a month with him, and he's heartily praying that the Wi-Fi lasts that long. So what are the key challenges of hospitality Wi-Fi? One of the key challenges are your guests, are your customers, because your client devices are literally changing every day, or perhaps more specifically every night. You will have multiple client devices per room, and your clients are not really being easy on your network because they're doing very taxing applications like streaming Netflix and voice calling and maybe FaceTiming or Skyping or what have you. So these are not necessarily easy applications. So that means that you really need a lot of bandwidth. One of the other major challenges is really a challenge of expectation. It used to be 10 years ago when I first started doing hospitality Wi-Fi. It was kind of, everybody expected it, but, some hotels charged for it, some hotels didn't. Some hotels had it, and they only had it in the lobby. Some hotels had it in the rooms. But there was always kind of well, if it works for you, great. And if it doesn't work for you, too bad. Well, now you go to a hotel and they actually want the Wi-Fi to act like it acts like when they're at home, right? They expect it to work just the same way it does at home. And in many hotel reviews, hospitality is a competitive business, especially in urban environments. And you often see Wi-Fi connectivity being rated even more importantly than clean sheets and towels, which to me is mind-boggling. But that's the reality of hospitality Wi-Fi. So if you're a hotel owner, you need to be providing excellent Wi-Fi. And that's a big challenge because your guests, it's not a typical network. On a typical network, your client population might be changing slowly, but it's not changing where every device is changing on a nightly basis. So you have this new and constant barrage of new and unknown devices that are hitting your network, and that is extremely challenging. So today I'm going to talk primarily about requirements and constraints for hospitality Wi-Fi, as well as some of the common solutions that one implements for hospitality Wi-Fi. But it's important to understand your requirements and your constraints in order to be able to design properly, because there's no one size fits all in hospitality or in any other vertical for that matter. But there are a lot of common threads and a lot of common requirements that you will see over and over again. And those are the ones that you really need to be aware of. Guest access obviously is primary, though in many applications, not your only application, and you need to be very well aware of that if the property is also using the Wi-Fi for other operations, which we'll talk about in the next couple of slides. While everybody's advocating 5 gigahertz and 802.11ac and soon 802.11ax, the reality is that you're still going to have quite a number of 2.4 gigahertz only devices, even modern 2.4 gigahertz only devices. My Kindle, for instance, is only 2.4 gigahertz. A lot of lower end Android phones are only 2.4 gigahertz. So even though people are generally bringing in reasonably modern client devices into hotels, you're still going to see a lot of 2.4. So you can't just be designing for 5 gigahertz. You really have to be designing for good coverage and capacity on both bands. Client isolation is also extremely important in hospitality, because I don't want a user in one room to be able to see users in a different. I want all of my users, all of my guests to get out to the internet, but I don't want them talking to each other. Most Wi-Fi systems will actually have some type of client isolation mechanisms in place, both within the AP. Some vendors will also offer some solutions that will work between APs. Otherwise, you got to do that on the switches. But you need to very much keep in mind that when you're designing and laying out your network, you need to worry about client isolation both within an access point, so for people in rooms that are connecting to the same access point, as well as between access points, so that your clients are isolated throughout your entire hotel. A lot of places still use captive portals, and we'll talk about captive portals towards the end. Captive portals are typically used for paid access, but you will see them a lot even for free access. You may also have hybrid models where a base level of service is offered for free, but if you want superior levels of service, then you're going to charge for it. The reality is that most people don't actually want to pay for Wi-Fi in a hotel. It is expected to be free. Some chains have linked this so that if you're members of their loyalty programs or frequent guest programs, then you can use that number and log in for free. So there are all sorts of ways that hotels are either giving it for free or they're pretending to charge for it, when in reality they're mostly giving it for free. That said, I still encounter hotels in my travels that are still charging for it. It seems crazy in this day and age to me, but you encounter that. When we talk about captive port,
I was going to chime in there real quick, Jason. I had this really great Wi-Fi experience recently at a hotel, probably one of the first pretty awesome Wi-Fi experiences there. And one of the key factors there was around the captive portal piece. There was no captive portal on the Wi-Fi. It was one of the first times it was at a major hotel chain, and there was no captive port. I don't know if you've ran into that or seen that at all, but I was pretty happy. Typically,
it's smaller hotels I have seen where they've moved away from captive portals, because as we'll discuss later, captive portals tend to be, they're expensive to own. They're generally difficult to configure. And they tend not to be implemented very well, which means that it's just arduous on users to get on the network. And typically in a guest environment, right, I want people to get on as easily as possible. Yeah. So many of the things that a captive portal had done in the past, in terms of rate limiting and so forth, are now often done by the APs. So you don't really need it for that. So yeah, you are beginning to see some hotels move away from the captive portal piece. And yet, I stayed at a hotel a couple of weeks ago where, they wanted $14.95 every night for the Wi-Fi. And I was like, the heck with it. I just ran the Wi-Fi on my phone, right?
Yeah.
Which basically was creating interference for anybody who wanted to actually use.
You must have been staying in a pretty nice hotel then, if they were charging for the Wi-Fi, because the not so nice hotels don't tend to do that.
Yeah, well, what you'll actually see in practice is that the hotels that are typically catering towards business class customers, so your kind of mid-range hotels, are generally offering the Wi-Fi for free, and your kind of top of the line kind of premium hotels are still trying to charge for it. I had got a really good deal on Priceline for the W in Austin, but part of that really good deal was they wanted to charge $14.95 for the Wi-Fi.
It's always a catch.
Yeah, well, there is always a catch. Depending on how they are controlling access to the Wi-Fi in the network, there may be integration of that captive portal with the property management system. And this is typically done if you're charging and you want to put the charge on the hotel bill. They need to integrate it with the property management system. Or often if you run into those captive portals where they ask you for your last name and your room number, those are typically integrated with the property management system to verify that, yes, you are the checked-in guest for that hotel room, and that's how they control access. Now, there may be, as I mentioned earlier, other applications that are going on the network besides guest access. You may have a staff network for internal operations, for your maintenance staff and for your maid cleaning service and so forth. You may have VoIP and VoIP over Wi-Fi. You might have IPTV. Now, again, some of these might not necessarily be wireless applications, but they're still applications on the network. You might have smart guest rooms. So you are seeing hotels now that are putting in smart thermostats and even smart lighting and all sorts of kind of fancy IoT type stuff. In New York City, it's not uncommon to see staff panic buttons because of an ordinance that was passed there a few years ago. So every single New York City hotel, the staff has to have a panic button, and they need to be able to locate where that staff member is within the hotel. And many of those systems work over Wi-Fi as well. So when we talk about coverage, right, we need to actually separate out the requirements for the front of house, which is what guests are seeing. So those are your guest rooms, right? The seating areas for your restaurants, your lobby, any banquet or conference facilities, versus the back of house, which is where the staff is operating. So that would be your operations, your kitchens, your point of sale operations. Because generally, right, you have very different requirements here, and generally I don't want my guests accessing my back of house operations, and nor do I necessarily want to allow things like point of sale operations on my guest room floors in order to be PCMCIA compliant. So when you're looking at coverage, you need to worry about coverage both for the front of house areas and back of house areas, and understand that the SSIDs that you're going to be running and who's allowed access and which sections of the facility may be different on a section by section basis because of these requirements. Of course, one can't talk about hospitality without talking about capacity, because bandwidth utilization within the guest rooms is moderate to high. You will have in-room video streaming, you'll have Wi-Fi phone calls and FaceTime calls. You may have multiple devices per room. If you have if it's just me as a business traveler, I still have my iPhone, my laptop, my Kindle. Now if you have a family in there and they've each got 2 or 3 devices, you could very quickly have quite a number of devices in an individual hotel room. If you're a hotel that's running a conference center or a banquet hall, you're definitely going to have very high usage during events. Keep in mind, though, that your peak usage times are not during business hours. They're actually during the evenings and weekends when people are in the guest room. So, most of us from a kind of a conventional kind of corporate Wi-Fi background tend to think of, I can just do upgrades on the nights and the weekends because nobody's there. No, nights and weekends are actually your busy time, right? When you want to actually do an upgrade, or if I need to swap out a switch or reboot things, you actually want to do that in the middle of the day. And it's a little counterintuitive, but that's because that's when you're going to have the least number of people on the network, at least in the guest rooms, right? For conference centers and banquets and meeting halls, that might be different.
Hey, Jason, Timothy in chat here said, he agreed with your point there around the cellular over Wi-Fi piece of it, needing to factor that in nowadays, because as more and more users enable that on their devices, obviously that can put additional load on the Wi-Fi network. But yeah, if you're in a situation where you're in an area with bad cellular coverage, that can also improve the the customer experience that is staying there. Yeah, maybe it puts a
Yes.
little extra load on the Wi-Fi, but improves the overall customer experience for the calling piece of it.
And in newer buildings, especially if they're LEED certified, right? So they've got argon or what have you in the windows to kind of keep, make them more energy efficient. One of the side effects of that is that they also tend to block RF signals like cellular signals from outside. So a building that's LEED certified will actually tend to have very poor cell reception inside. And hotels in the past have often had to deploy rather expensive DAS systems for guests to be able to use their cell phones. But with the prevalence of Wi-Fi calling, you're just seeing a lot of, you're seeing more and more places that are just saying, just the heck with it, let them just make the calls over Wi-Fi, because it's obviously much cheaper to deploy. That said, it's obviously more taxing on your Wi-Fi network, so your Wi-Fi network needs to be much better than that. In terms of monitoring and control, typically a hotel is not running their own service. They will typically outsource Wi-Fi to a wireless internet service provider. And the AP vendor and the WISP that you're allowed to use is sometimes dictated. So sometimes the hotel chain is actually saying you can only use one of these integrators and you must use this particular AP vendor. To me, that this is a very backwards approach, because the vendors who have that skill, I'm sure, love it. For vendors like me that don't, right, obviously don't love it. But it's backwards to me, because I need to understand my requirements and then pick the right devices for the requirements and pick the right vendor to provide those requirements. And because even within the same hotel chain, right, not every hotel is created equal, and the requirements are going to be different from one property to another. And you're going to want to pick the best solution that meets your particular requirements, and not just say, hey, like, this is what I have to use because this is what the corporate is telling me that I have to use. Unfortunately, though, many chains, they will actually dictate who you're allowed to use in terms of integrators and who you're allowed to use in terms of vendors. And they try to do that from a quality control standpoint, but it can be self-defeating. Whether, of course, they're dictating that or not, one of the challenges that you often have in hospitality environments is that you are not the only vendor in those closets. So if I have, an NF and I've got IDFs every 3 floors or whatever, well, you know what? I've probably got separate vendors for any surveillance that's going on. I probably have separate vendors for the VoIP network. I've got separate vendors for the television. You may have a separate vendor for point of sale, and what you're going to wind up encountering is that you're going to have many different vendors who are either trying to kind of, say, hey, I have a separate VoIP vendor, but I need to backhaul them on my switches. So, or they've got to share the internet connection, or I need them on a separate VLAN, and then they're going out their own internet connection. It's not unusual for a hospitality property to actually have 4 or 5 bandwidth circuits coming into it. They'll usually have at least one for the guest network. They'll have a separate one for the staff network. They may have a separate one if they're doing VoIP. They may have a separate one for doing IPTV from so it's not unusual to actually to go into an MDF and actually see 4 or 5 different modems, often from different bandwidth providers that are put in there by the different vendors who are providing different aspects of the guest experience. So it's usually not all done by the same vendor.
That's interesting, Jason. I'm curious, like, at what you've seen of that. I'm assuming there's got to be some scale to that, right? Like, the larger the property is, the more diversity, if you will, of different ISPs, different WAN links that you're going to have. Have you seen any kind of scale to that? I'm assuming a smaller operation with just a certain number of rooms, let's say, would you tend to see maybe just 1 or 2 connections versus a larger organization having 4 or 5?
Yeah, well, I mean, you're typically going to see, even in relatively small operations, you're typically going to see multiple vendors, because you almost always have a separate vendor for the phones, for the TV, for the internet.
Okay.
So even in a relatively small environment, you're going to have at least 3 vendors.
Okay. So it's more the
For
services you
larger
provide there.
chains, typically their internal IT department will be providing stuff for the back of house and perhaps point of sale. So that will be controlled by corporate. And they want to generally keep all of their stuff completely independent of what's going on the guest network, because they don't even want to deal with the guest network in some environments. In other environments, they need those to backhaul. So because they don't have the wiring infrastructure, so it can vary not only from chain to chain, but even from different properties within a chain.
Interesting. Okay. Yeah.
But
Good info.
you will generally encounter, even at small properties, you will generally encounter multiple vendors because you will typically have phone, TV, and internet by a separate vendor. Now TV might be coax, right, and be completely separate wiring and completely unrelated. At the same time, though, their equipment's also going to be in those closets, which means that you're going to be limited for space. And I have seen instances where one vendor has accidentally messed up the equipment for another vendor. Stuff gets unplugged and so forth. These things happen.
Mm-hmm.
So, it's something that if you're working in hospitality, you're not the only kid in the sandbox, and you got to play nicely with everybody else. And that can lead to its own set of challenges.
Interesting. Okay. So obviously
VLANs,
that's
by the way, are
something
very, very common. So where you do have to share the wire infrastructure, let's say between phones and TVs and such, and, say I only have one set of wiring going into each room, you will need to share the infrastructure, including the wiring infrastructure, which generally means typically the way that most WISPs do this is that they'll carve out a separate VLAN for the phones. They'll carve out a separate VLAN for the the IPTVs and so forth. And then it's basically like, here's where you're allowed to plug in and then do what you want, right? Here are the ports that you're allowed to plug in, right? And as long as you keep to those ports, then we're good.
Yeah, that makes a lot of sense.
In terms of infrastructure and integration, you may or may not have Ethernet ports in each room. Newer hotels tend to be built with Ethernet, sometimes even multiple Ethernet ports in each room because, again, I'm running phones, I might be running the TV and such over the Ethernet. Older hotels, often they don't have any Ethernet wiring into the rooms, and there's no real practical way of getting Ethernet wiring into the rooms. You may or may not also have dedicated IDF closets. I have seen very frequently where the IDF closet is literally a switch that's tucked in on an upper shelf in a maid's closet or in some other, closet that's used for other purposes. If you have a property where you're doing like a motel or just even a hotel that has multiple buildings and multiple structures, you may or may not have cabling infrastructure between the neighboring buildings that make up that property, which means now you're looking into point-to-point links in order to interconnect those buildings. So keep in mind that always the wireless network is always going to be only as good as the wired infrastructure that supports it. And this is key. If the wiring infrastructure is really, really lacking, there's only going to be so much you can do with Wi-Fi. So what we've been talking about up until now are requirements, but we should also mention constraints. Budget's often a big constraint, especially for smaller and independent hotel chains. Aesthetics is usually the biggest constraint that you run into. You may have, as I mentioned, mounting restriction locations and wiring infrastructure constraints, right? If I have wiring in the room versus I can only get wiring down the hallways, right, I'm going to be deploying a very different kind of network. You may also have external interference. So if you're doing a hotel in an urban or dense suburban environment, chances are good you're going to have external interference from neighboring buildings. If you're a hotel out in the middle of nowhere, well, maybe I don't need to worry about that. Aesthetics tends to be kind of the biggest and most annoying constraint of these because many hotels don't want to actually see the access points. They want the access points hidden. And they care more about aesthetics than they care about how well the system actually works. And I've had people say, no, we want the APs above the ceilings. Don't care. We don't want to see them at all. And this is, people don't like seeing antennas, but now they don't even like seeing, your APs with your built-in antennas. Now, usually what I explain to people is, there's a reason that you don't put, the sprinkler system heads above the ceiling, right? Why don't you put the sprinkler system heads above the ceiling? Besides the fact that the fire marshal won't let you put the sprinkler system above the ceiling.
I know the answer. I know the answer.
Yes.
Because they won't work.
Oh, great answer. That's a great answer. Of course, people have now actually found ways of actually hiding the sprinklers so that they pop down in the event of
Oh
an
yeah,
emergency.
yeah, I've seen that.
Right.
Yep. Little covers.
But of course, when Wi-Fi is being used all the time, I can't just exactly just have the AP just kind of pop down when I want to pass traffic. You know, APs typically can be painted. I've been in environments where we've had to paint the outer cases of APs for aesthetics reasons. But it can be often a big challenge to kind of meet aesthetics constraints, especially. But all of these constraints are important, but aesthetics usually is the one that's like banging your head against the wall in terms of trying to explain that, no, if I put it above the ceiling, it will not work. So let's talk about kind of, your general rules for design at this point. So as I mentioned, aesthetic constraints, right? Typically, you're going to wind up using indoor APs with internal directional antennas, right, that have a small footprint. If Ethernet wiring is in the room, a lot of vendors have wall plate APs, because I can just literally mount those on the wall jacks. And I don't need to run separate cabling into the room, which is great. And most of those APs typically have, two or three additional ports on the bottom of them. So you can actually, run things, I could run a wire to the IPTV. I could run a wire to the VoIP phone. Keep in mind, though, that typically wall plate APs, I don't necessarily need one per room. So most vendors, when they're selling you wall plate APs, will try to sell you on the fact that, hey, you really need one of these in every room. You really should only do that if I really need a switch in every room, because the wall plates APs have a built-in switch that generally can adjust the VLANs per port. If not, and you're primarily just using it for Wi-Fi access, or if I only need one Ethernet feed out of it, you generally will get enough coverage out of a wall plate AP to cover 2 or 3 rooms. So you may or may, and that will depend on the size of the room. It will depend on the building materials between the rooms. But very typically, you don't actually need one wall plate AP per room. APs rated for SMB applications are often sufficient. Quite honestly, most hotel environments don't require a Cisco or an HP Aruba, where you have large and recurring, ongoing licensing and operational costs associated with that. Most hotels, especially smaller hotels, quite honestly, they don't want the ongoing costs, right? They'll typically have some capital budget in order to do an upgrade, but they don't necessarily have room to increase their operational budget. So when you're picking your APs, you need to understand the budgetary constraints, not just from a CapEx perspective, but from an OpEx perspective, from an operational perspective. At the end of the day, understand the requirements and constraints before actually picking the AP. Unfortunately, most WISPs, as I mentioned earlier, tend to pick the vendor and models that they're most comfortable with. And again, many chains also will dictate what AP vendor to use. But if you're picking the AP vendor and models that you're most comfortable with, that doesn't necessarily mean that that's the right choice for this particular application. So understand your requirements and then pick your APs based on your requirements, not the other way around.
Jason had a couple of comments here in chat around the aesthetics, and Jason, one of the comments here, says he's a hotel owner, and he says it's not just aesthetics alone, but also due to theft and guest tampering, is another constraint on the hospitality side that you don't have to necessarily think about in other industries.
Yes, I have environments where there is concern about guest tampering and guests unplugging the APs and guests just taking the APs. I have seen that. I have seen that in some hospitality environments. So yes, that issue does come up from time to time. I have seen that.
Yeah, and then that leads to things like Timothy also had an interesting comment here about a hallway only installation about the aesthetics, and then also requiring to put the APs inside of like NEMA enclosures or some type of metal box to protect the AP as part of like the constraints there. So obviously a lot of a lot of challenges to try and overcome, in that type of situation.
Yeah, I mean, if you want to get into hiding the APs, and I mean, there are companies that specialize in those types of enclosures, right, to hide APs. If that's a requirement for you, and you're really worried about somebody taking these and unplugging them and walking off with them, then yes, that's a requirement on your environment, and that might dictate, yes, I need to put them in the hallways, and yes, I need to put them in locked enclosures and so forth. And because of the type of property that I am in, and the location that you're in and so forth, and your the types of guests that you typically have, yes, that can be a requirement, and that might be sometimes your constraints will kind of outmode your requirements, or sometimes you'll have requirements like that where, no, I'm really worried about guests tampering with the APs and stealing the APs. So, that might lead you to make different design choices. Absolutely.
Yep. Seen all sorts of fun stories and hear about stuff getting stolen out of housekeeping closets and things like that. So yeah, there's
Yeah, I
definitely
mean,
some extra
generally
consideration.
your IDFs should, you want your IDFs to be in locked rooms. Many hotels, though, don't do that. A closet that's readily accessible to guests, or they're in a housekeeping closet that if the housekeeper leaves it open, then all of your switches and equipment are sitting right there. So yes, I mean, there are obviously trade-offs in some properties, right? I don't, some properties need to worry about that more than others.
Yep, definitely.
In terms of locations, the general rule for placing APs, and this is not just for hospitality, but in general, is I want the APs to be as close as possible to the client devices with as few obstructions as possible. And I want my APs to be as far apart from each other as possible with as many obstructions as possible. Because I don't want my APs talking to other APs, I want my APs talking to clients. Typically, what that means is that in-room deployments are virtually always better. However, if you don't have wiring in the rooms, or if you have this case where I'm worried about tampering of the devices, then you might have to do a hallway deployment, and then you're going to be constrained to be doing a hallway deployment. Most client devices tend to have much weaker transmitters than the access points. So when you're placing the APs, you need to place them in such a way as to facilitate the client's ability to talk back to the AP. So basically the AP's ability to hear the client. This is usually a counterintuitive concept. When I've worked with installers, this is a concept that they tend to have a hard time with at first, because you tend to think, oh, I'm placing an AP and the AP's got to talk. And that's true, but the AP also has to listen. And actually listening is actually harder than talking, because the AP will be shouting, but the client devices will be whispering by comparison. When we talk about power in a couple of slides, I'll get into that in a little more detail. But suffice it to say that you need to place the APs so that the APs can hear the clients, not so that the clients can hear the APs. And this is it's a very important concept, but it's a concept that's often very counterintuitive for people that don't really that don't have a very good understanding of RF. So here's an Ekahau predictive model example of why hallway deployments are bad. Again, sometimes they're unavoidable, but typically if I have the option of putting them in the rooms, I want to put them in the rooms. So on the left, what you're seeing is, so the top row is basically the signal pattern, the bottom row is interference. Red is bad, green is good. So what you're seeing on the left is when I put the APs in the hallways, I've got lots of signal in the hallways, but I've got lots of rooms where the signal is poor, and even areas in some rooms where, like in the middle there behind the elevator, where the signal is practically non-existent. And what that means is I'm going to get poor coverage in those rooms, and I'm going to get poor user experiences because the signal is either going to be slow or it's not even going to work. The other problem that you have with a hallway deployment is the level of interference, especially on 2.4. Even when you're using static channels, you only have 3 channels. So on your fourth AP, if I go 1.6.11, well, on the fourth AP, I got to use 1 again. And the hallways themselves actually serve as a lens to kind of, direct the signal down a straight hallway. So AP, those APs are going to see each other, and then they're going to interfere with each other, and you're going to have a large impact, especially on your upstream traffic. On the right, it shows you the same hallway where the APs are put in the rooms. In this particular example, it's actually the same number of APs. They're just placed in the rooms versus in the hallways, and you can see the signal coverage in the rooms is much, much better. You might have a few kind of weaker spots in the hallways, but people aren't using the devices in the hallways; they're using them in the rooms. And your channel overlap is also, you have very little to worry about in terms of co-channel interference. So on 5 gigahertz, usually co-channel interference can usually be completely avoided. On 2.4, usually it can be minimized, if not completely avoided, depending on the geometry of the layout as well as the building materials.
Yeah, I think a big thing to highlight here, you mentioned it, but just to call it out again, the design on the left to the design on the right is the exact same number of access points, but drastically different story when it comes to the RF and how much more optimal the RF is in the spectrum, right? So we're making much better use of the spectrum by staggering those APs out, using the actual walls and the construction of the building to actually optimize the RF environment.
Yeah, and Jerry, it's a very good point. Typically, I've found that in this particular example, it's the same number of APs, which is a great example. I found in practice, often you might need a handful more APs when you're doing in-room deployments versus a hallway deployment, but the benefit in terms of the user experience more than outweighs the additional cost of those APs. But in this particular example, it's the same number of APs, which is a very good example. But usually, it's been my experience that it usually takes it takes a few more APs, depending on how big the property is.
Yeah.
In terms of channels, understand your throughput per user requirements. You don't always need to use larger channel sizes. In fact, if you're constraining the users to your captive portal or within your Wi-Fi controller to 5 megs, up and down per user, or 10 megs up and down per user, which is not atypical for controlling the bandwidth per user. Well, you know what? I don't need an 80 megahertz channel on 5 gigahertz in order to provide 10 megabits of bandwidth to a user. So you always want to avoid 40 megahertz channels on 2.4. And even on the 5 gigahertz, you generally want to be using 20. In most hotel environments and smaller environments where you've only got a handful of APs, you could get away with 40. Again, though, this should be dictated by what your bandwidth requirements are for the users, coupled with the expected number of client devices on them. But if you're using smaller channel sizes, you have more channels available, and that will help you minimize self-interference. And every successful Wi-Fi deployment, in my experience, in any vertical, requires avoiding or at least minimizing the self-interference between neighboring APs. That really is your number one killer. And that's also something you have complete control over. If they're your access points, you have control over what channels they're broadcasting on. So control it. Transmit power is kind of the other main knob that you have when you're doing these types of designs. If the AP power is too high, you can create kind of a false sense of coverage. So if your AP is broadcasting at 29 or 30 dBm, that's a watt of power. Your AP is screaming. AP is really, really loud, which means that a client device can hear that AP from very far away. The client devices, especially modern tablets and smartphones, tend to have very weak transmit devices. They have very weak transmitters, and hence they are whispering in response. And so just because you can hear the AP doesn't mean that the AP can hear you. But Wi-Fi is kind of one of the inherent assumptions in Wi-Fi is that the connection is reasonably symmetrical, which means that I can hear as well as I can be heard. And when you have a big mismatch in transmit power, that assumption is no longer true. The other thing that you need to worry about, especially when doing dual band designs, is that 5 gigahertz doesn't travel as far. It attenuates faster through walls and so forth. But if I'm placing, dual band APs, then I want the coverage area per AP to be roughly the same on both bands. Typically, I would advocate a static offset at least 6 dB. The key message here is that your effective coverage area is really driven by your client device, not by your access point. Finally, let's talk a little bit about captive portals. So what is a captive portal? A captive portal is a layer 3 device. It's typically used on open networks that don't have encryption, and they're designed to control who has access to get out to the internet. Now, because it's a layer 3 device, a captive portal typically doesn't care whether the client is wired or wireless or connected via 2 cans and a piece of string. It won't care. It's at layer 3. The appliance may be standalone. It may be cloud managed. Many captive portal platforms have been cloud managed ever since before the term cloud management was a thing. But that just means that they were centrally managed from an internet site. Typically, with a captive portal, it gets a splash page when they log in, and they need to acknowledge terms of service. And by terms of service, it basically says, I'm not going to abuse the network. I'm not going to torrent things. I'm not going to hack my fellow users. I'm not going to try to break into the NSA, that type of legalese that nobody ever reads. Now, these devices could be problematic because you have a lot of gaming consoles and even things like Kindles and so forth, where I have internet devices that want to get out to the internet, but they don't have browsers. And if they don't have browsers, they can't pull up a captive portal splash page in order to be able to log in. So those devices usually need to be authenticated manually by the network administrator. The reality of captive portals is that most of them are fairly expensive appliances. They're difficult to configure, and they generally just complicate access to users in order to be able to get them on the network. They also tend to, when they're implemented, they tend not to be implemented very smoothly. It isn't even so much of a problem as to whether or not a captive portal is used, but you can deploy captive portals reasonably well to make it as easy as possible for users to get on. Most, unfortunately, are not actually deployed that way. Most of them, especially in larger hotel chains, you seem to wind up having to click on several buttons and go through several screens before you actually can get on the internet, which is extremely annoying. And then if you're off for 5 minutes, you may have to go through the whole process again.
That's exactly what I was thinking of. You go through all those steps, and then an hour later or whatever, even 15 minutes later, all of a sudden you got to go through the whole process over again.
And even typically what will happen is, if they're well designed, typically you'll be MAC authenticated. So after the first time you log in, when you attempt to, if you go off the network, let's say you leave the hotel and you come back, and you're within the time frame, it'll say, hey, I recognize this device, I recognize the login, I'm going to skip all of this step and just going to let them log in. Even then, typically the default is a day. So if you're staying at a property for a week, you keep having to log in every single day, once a day. And you might even, and typically it's a 24-hour timer, so you might be in the middle of doing something and all of a sudden you're getting a splash page, right when you're in the middle of something, because that's when your 24-hour cutoff was. Again, they can be designed well and they can be deployed well and deployed intelligently. And unfortunately, most people don't. And that's why people hate captive portals. Is not even because they're inherently bad, but because they tend to not be deployed well. Now, in terms of login options, there are lots of different login options that you might see in a hotel. If for free service, you'll typically just have terms and conditions where you say, yes, I agree to the legalese that I'm not going to read. You check a box, you hit OK, and away you go. You might have a username and password. Many hotels will use a rotating user code. So they'll give you a code at login that's good for, and that code changes on a weekly basis. It's typically like a 4-digit code or a 6-digit code, and then you punch in the code, and then that code gets you on the network. If you're tied into the property management system, you may get asked your name and your room number. I have seen hotels where they've asked for social media and email. And I've even seen a couple of places where, it's all ad driven, because a lot of captive portals, one of the ways that they try to justify their expenses saying, hey, you could sell advertisements, and then make back some of the money for this expensive by selling advertising space. Most users don't want to see advertising. There's enough advertising on the internet without having to force people to watch advertisements before they can get on the network. Now I showed it here as may constrain bandwidth per user, but this is actually a very common application for captive portals, is to actually limit the amount of bandwidth per device or per account, so that I don't have somebody running BitTorrent and sucking up 90% of the bandwidth of the property. So it's very common to constrain the bandwidth to say 5 meg, 10 meg per user. Many Wi-Fi platforms, though, now have that functionality built in, where they will constrain the bandwidth per user at the access point, so I don't need to be doing it at captive portal. But that was a very common application for needing captive portals for a very long time. And captive portals are still very, very common in hospitality environments. And many of the captive portals that are in the market are specifically for the hospitality vertical. They're specifically designed for the hospitality vertical. In terms of wired network infrastructure, other deployment considerations, right? Understand your wired network infrastructure. Understand you might need to run cabling. You might need to do point to multipoint. Your controller architecture, whether you're going to be standalone or centralized or distributed, will often depend not only on vendor choice, but on what your monitoring and control requirements are. And again, tools like Ekahau are very useful for doing site surveys. In the 3 main surveys that you could do, I could do a predictive model, which will give you it's based on the quality of the inputs, will tell you the quality of the outputs, but that will often give you kind of a reasonable first pass at what the deployment looks like, how many APs you're going to need, where you're going to need to put them. You should always be doing at least a post-deployment survey to kind of make sure that everything is working the way that you expect. And pre-deployment surveys, going out there, placing the AP on a stick, taking measurements, seeing how the signals are propagating through walls are always very useful. Unfortunately, you tend to be constrained by budget on this because most hotels don't want to pay for site surveys, and running site surveys, as we know, requires sending a trained engineer on site to walk around for a day or 2 or 3, depending on the size of the property. So many places don't want to pay for this, so often this step gets skipped. If you can build in the cost either directly or build it into the cost of the deployment, and build it into the cost of the infrastructure that you're going to build. If you can actually cover these costs, it's always a good idea to be doing this. The more information you have about the environment, the better your ultimate deployment is going to be. At a minimum, you should always be doing predictive modeling at a minimum, because that really doesn't cost all that much. All you need is floor plans to scale and some understanding from the property of what's going to be there. But the more that you actually can get on site, and the more that you can actually see, hey, this is where I can run wires. Hey, this is where I can actually mount APs. Hey, these walls are actually concrete, not drywall. The better your design is going to be. So in conclusion, to kind of wrap it up, then we'll open it up for questions. Understand the key requirements and constraints of the hospitality environment. Hospitality is mostly, but not entirely, about the guest experience. Select the right AP for the application. It is not a one-size-fits-all vertical. There's a huge difference between in-room versus in-hallway deployments. Again, though, sometimes for either because of wiring constraints or because of theft constraints, sometimes you will be required to do a hallway deployment, and you've got to make that work the best you can. Design your network to maximize the performance of the client devices and to minimize the self-interference between APs. Make sure your AP channels and transmit power levels are set properly. And keep in mind that captive portals, they're still very typical in hospitality. And if you do need to deploy a captive portal in your environment, make sure you deploy it well. Now, we do have a white paper that I worked with Ekahau to author on hospitality Wi-Fi. It goes into the stuff that we covered in this webinar in a lot more detail than I had time for in this session. So I encourage you to go to Ekahau's website and download the white paper and read about this stuff in more detail. And with that, let's open it up for Q&A.
Yeah,
Yeah.
thanks, Jason. That was awesome. We had a lot of great dialogue going on here in chat and a lot of questions that I was kind of flagging here to bring up. So I know we're already a few minutes over from the 45 minutes we had set up for this, but it's a lot of info to try and cover here. So let's see. Still got a lot of people on the line. So yeah, if you're open to sticking around for another 15 minutes or so
Yeah,
to answer some questions.
I'm fine with that. So yeah, I'm
All right, I
happy to stick around
appreciate
and
it.
answer some questions.
Awesome. All right. So the first question we've got here is actually not specifically related, I guess, to hospitality, but more, similarly, the college and university side. Do you have any experience with that side of it?
Oh yeah,
More the dorm room.
I've done student housing, both public as well as like private student housing. So like off
Excellent.
campus student housing.
Yes. So the
Um,
question is around the considerations on that side of things, and are there any special requirements beyond what you covered here on the hospitality side?
yeah, I mean the requirements are similar. Obviously, you're not getting nightly change out. The requirements in terms of coverage and such are similar. The biggest differences are that students tend to consume a lot more bandwidth. They tend to have a lot more devices. They tend to be streaming a lot more. They tend to be doing a lot more uh, dubious activities like streaming, BitTorrent and so forth. It's not uncommon to see students actually streaming multiple Netflix things at once. Um, I,
Nice.
I can't multitask that way, but perhaps I was never that young. Um,
Gaming
yeah,
consoles.
gaming's also huge, and also with gaming, most gaming consoles don't have browsers on them. So typically, the IT department or the WISP that's running the student housing will need to Mac authenticate those in advance in order to get them on the network. I've been in student housing environments where we've actually made up separate SSIDs on separate VLANs just for gaming consoles, so that don't go through the captive portal.
Right
And
on.
typically, those are restricted in terms of bandwidth, um, so that you don't have kind of normal users kind of jumping on those um, for like streaming video, because typically with gaming, um, what you're worried about more is latency than even so much the throughput. Even for the graphics intensive games, the graphics engines are local, and what it's doing is you're driving the changes, but the changes tend to be not that much data, but your latency is obviously key there. So you will get requirements in terms of very low latency environments, and for that type of environments, it's not just about the signal, and it's not even so much about throughput; it's about latency in those cases.
Okay. The next question we got here is from Karthik. This is kind of more of a, let's see, a design challenge we'll throw at you and see if you see if you can make this work. He said for hotels, many chains dictate that they want corridor elevator with negative 65 dB at on 5 gigahertz. Is that something that if you were throwing that kind of design constraint or requirement, is that something that is feasible?
It is feasible. You'll wind up using more access points, and if I want 5 gigahertz coverage in the elevators, you're putting an AP in the elevator. Um, and if you have older elevators that don't have the Ethernet run cable on them, then it means you're putting point to point in the elevator shaft in order to get signal into the elevator. In order to get network connectivity to that elevator cab. So it is doable. It is certainly doable. I've seen networks and deployed networks where we've had to do that. You wind up with more access points, and then you have the trade-off of co-channel interference.
Any
Everybody tends to measure everything in terms of bars, right? So in terms of signal strength,
Yeah.
but signal strength is only one piece of the puzzle.
Yeah.
Unfortunately, that's the piece that everybody, it's an easy piece to understand. It's an easy piece to visualize. And so that's what everybody focuses on. But that's not the only metric.
What if we are constrained to only putting APs in the hallways, and we still want to try to achieve that, negative 65 dB at 5 gigahertz, throughout the hotel? Is that
That's
obtainable? How would you?
depending on the building materials, it's probably not going to be possible in practice. Quite honestly, if
Any
you need like neg 65 everywhere, you're going to need to put them. You need to have the APs in the rooms, and at that level, you might need those wall plate APs in every room to achieve that level of signal.
What about
Uh,
other types of antennas and things like that? Anything that you could use to try and help with that of still keeping the APs in the hallways, but steering that signal where you need it?
Yeah, I mean, I've seen people play tricks with directional antennas and stuff. The problem is you have to go through. I got to go through all that structure, right? I've got to go through a door which may be metal. I've got to go through, a bathroom which have mirrors and tile and stuff in it that tend to attenuate signal pretty drastically. And that's between my client device and my hallway AP. I mean, in theory, you could put, I could do funky things with antennas. I could put an AP literally outside like of every pair of rooms. But my co-channel interference is just going to go through the roof at that point, and your overall performance is going to not be as good. So,
Yep.
but I've seen RFPs written that way, and yeah, that I mean, again, when you have a hammer, everything looks like a nail. If I'm only focused on signal, then I'm going to design to signal, but then I'm going to have high amounts of interference, and I'm not going to get what I actually want, which is performance.
All right. Next question we got here from Howard. He's got a client with a AP deployment that's requiring every single guest room have its own AP in there. Is there any issues with that? What would you say if you had a customer that was kind of dictating that?
So if you're putting what I've done in environments where I've had to put APs in every room, and I have had requirements like that, is I'll typically turn off the 2.4 radio on at least half of them. Because the 2.4, remember, propagates a lot further than the 5 gigahertz, and even when you turn the power way down, you're still going to, that 2.4 gigahertz signal is still likely to travel a lot further than the 5 gigahertz. Yeah. So you need to plan your channels extremely carefully. And you should plan on turning off the 2.4 on, I would say, probably at least half of those APs. So all of the APs are going to be broadcasting on 5 gigahertz, and maybe half of them, maybe even less, will be broadcasting on 2.4.
Kind of an additional question along those lines was stagger. If you have a multi-floor environment, do you stagger the APs? Do you stack them on top of each other? Does it make a difference?
Yes. So you generally, it depends on what the building materials are. You typically want to stagger between floors. So we didn't really kind of talk about the positioning here. But you generally want to stagger. When I'm doing in-room deployment, I want to stagger. I don't necessarily want two APs like immediately across the hall from each other. So I want to stagger them horizontally. I also want to stagger them vertically. And typically what that will mean is, if I think about it as just a simple kind of straight hallway deployment, like typically, they'll be deployed in kind of like a W pattern kind of going down the hallway, and you're going to invert that on the opposite floors. So typically you might be repeating that pattern every other floor, and then the APs are staggered on. So I'll have a pattern of APs for the odd numbered floors and a pattern of APs for the even numbered floors. So you typically want to stagger that. A lot of it will depend upon what the building materials are. It's very common in modern construction. They use gypsum for the flooring because it's thin and it's solid and it's relatively inexpensive. It also happens to be completely transparent at 2.4. It's like glass at 2.4. Less so at 5, but at 2.4, it's extremely transparent. And so if you stack the APs from floor to floor, you might get a somewhat counterintuitive scenario where I can see the APs above and below me better than I can see the APs on the same floor. So when you're designing for a multi-floor environment, you need to design three-dimensionally. And you need to keep in mind that sometimes the attenuation through the floors may be less than the attenuation through the walls.
Excellent. Changing gears a little bit here, John is asking about capacity requirements and if you have any tips for estimating capacity, particularly for outdoor areas, lobbies, etc.
So, you want to look at, it depends on the environment, but I mean, what you're going to want to look at is basically what's the, typically the fire marshal will they'll require a rating of how many people can be stuffed into a particular area. And then, you have to figure out what you're going to use that environment for. If I'm going to be, if it's a conference room where I'm going to have lectures and stuff going on, chances are I'm going to have a lot of high usage. If it's primarily like a banquet, or like an outdoor reception and such, your actual number of users may be, a half to a third of the rated capacity of the space. So it very much depends on the use case. But you're definitely going to want to look at, and again, this comes back to requirements of understanding how the network is going to get used. But for those types of environments, you definitely want to understand, all right, what's the rated capacity of the space, and then how is that environment generally getting used, and then from that you can generally estimate how many devices you need to design for. And that's even true for indoor areas like lobby areas and such. Typically a lobby area is not necessarily going to be hugely crowded unless people are just waiting in line to check in. But you might have scenarios where you have a whole bunch of people waiting to check in and they're all on their phones and they're all trying to get online. So that's what you need to design for.
Okay. Changing gears again here, Alex asks around AP selection, and how do you, any tips on kind of properly selecting the AP for this kind of deployment? What's your thoughts on there? How do you figure out what is the right AP for design? What kind of considerations there?
Typically I'm a systems engineer by background, so for me, everything always comes back to requirements. But you're typically going to want to look at what that AP needs to do. If I'm only providing guest access, I don't need some of the fancy features that you're going to see in some of the very high-end vendors. Now, if I'm doing kind of real-time location positioning, or if you're doing some other Bluetooth beaconing or other things, and maybe you do need APs of that caliber. But if you're doing kind of straight guest access, an SMB rated access point is going to be generally just fine. That's in terms of picking vendors. And then within a vendor, typically you're going to have models that have either, internal antennas versus external antennas. People don't like looking at antennas, and even if you don't have explicit constraints about aesthetics or explicit constraints about tampering and interference, you're generally going to want to have internal antennas in most of your environments, simply so that they are less noticeable. And also because when you have external antennas, especially multiple external antennas that are sticking out of the AP, people love to touch them. I don't know why, but people love to touch them and move them around. And then they're out of alignment, and now they're not performing MIMO as well as they can be. And that will just degrade your performance. And, so I would almost always stick to internal antennas. Quite honestly, the only reason that you would want to use an AP with external antenna ports is if I'm putting on some type of directional MIMO antenna. So if I'm in if I'm covering like an outdoor courtyard or something, and I want to put a sector antenna, I want to mount the AP in the corner and mount the sector antenna on there. And it would make sense to pick a model with external antenna ports that I could put a sector on. So, for example, but typically for an indoor deployment where I want omnidirectional coverage, use the models with the indoor antennas, with the internal antennas.
Makes sense. All right. Well, we're a few minutes over the top of the hour here. How about 2 more questions? Does that sound good?
Sure.
We got quite a few we're unfortunately not going to be able to get to, but maybe Jason, if you're cool with it, maybe put your Twitter handle or something like that in chat, and we'll make sure.
In fact, actually, I'll put it back on the. If I go back up to the top, let's find the home button here.
Excellent.
My Twitter handle is Emperor Wi-Fi. So if you have questions, feel free to reach out to me on Twitter, or post the questions, and I'd be happy to respond to stuff on Twitter. So if you have additional questions that come out of the webinar that we don't get a chance to talk about today.
Cool. Well, Peter's got a good question, I think, here around client isolation that you mentioned. He understands that, it's for helpful, or he believes it's for, preventing a device that's connected to the wireless network from accessing something on the wired side of the network. But does it also prevent wireless clients from communicating with each other?
Yeah, so client isolation, I could do a whole webinar on client isolation, but because client isolation itself can be a rather complex topic, and multi-layered topic. In general, though, for your hospitality environment, you generally only want your guests to see the internet, and I don't want them to see anything else either on the wireless or on the wired side of the network. So typically, for staff and back of house applications, you'll typically isolate things using different VLANs. And if they're wireless, then different SSIDs broadcasting different VLANs. But even within an SSID, so even within the guest network, you want to isolate the client devices from each other so that they can't see each other. I remember being in a hotel years ago where you could run, iTunes and you could basically just look for neighbors and you could see other people's music libraries of just other guests in the hotels from their laptops, because you can't assume that people, even in this day and age when the firewalls are built in and so forth, you can't assume that clients are running any type of firewall software. When you're responsible for the infrastructure, you need to be responsible for making sure those clients are not talking to each other.
Excellent. All right, so there's one more question here that I saw that I thought would be a good one. So this is actually around using the Ekahau site survey software. Josh asked, do you see that the predictive survey that you do in Ekahau, does that yield roughly the same results as that pre-deployment AP on a stick survey? What have you found there?
What I found is garbage in, garbage out. So the more accurate information that you have about especially what the walls are made of, the interior and exterior walls, and the more accurate information you have about the layout, the more accurate that your predictive model will be in terms of your final design. Very often I've done a lot of deployments where the only thing we can do is predictive modeling because, especially from the AP vendor side, I can't send, I'm typically not sending engineers to the site. And neither the integrator nor the hotel owner wants to pay to have for an engineer to come out with Ekahau and take all those measurements. So sometimes predictive modeling is the only tool that you have from a practical standpoint. And again, the goal there is to get as much information as you can as possible. Generally, when I've done site surveys, there's always something that somebody didn't know. So there's always either the walls are, more transparent or less transparent to RF than was previously assumed, because in a predictive model, you're typically just going to use kind of the standard default values for drywall or concrete or what have you. But, the actual performance is going to vary. When you're in the environment and I have mirrors and I've got appliances and I've got, shower doors and I have all these other real things in the environment that are not modeled, those all have an effect on the RF signal propagation. That said, if you can, if your design is robust enough and you're saying, okay, I can put the APs in the rooms and I'm going to put the APs every 2 or 3 rooms based on the wall, and my signal strength seems to be really, really good everywhere, that can forgive a lot of sins of things that are missing from the model, because the model is based on a bunch of simplified assumptions. But the model will be wrong if those assumptions turn out to be wrong.
Yep.
So anytime you can actually get on site and do an actual survey and take actual measurements, you're always better off doing that. The reality is, though, sometimes you can only do a predictive model because that's all you can really justify in terms of cost. And that's just an unfortunate reality of this business.
All right, excellent. Well, I appreciate everybody coming on, and Jason, for you sticking around a little past the hour here to answer some more questions. I apologize for not getting through all the questions, but Jason has graciously put up his Twitter handle there, so feel free to either send a tweet at him or DM him with those questions, or you can email myself as well. Put that in chat if it's an Ekahau related question. Happy to take that offline with you. And get that question answered. So let me go ahead and put that in here. It's just going to be jerry@ekahau.com. And I also did put a link in chat there to the white paper that Jason did help us put together. Did an excellent job with that. So that covers a lot of these same kind of topics that Jason went through, in this 45-minute presentation in much greater depth. So definitely recommend reading through that. But yeah, thanks everybody again for attending today's webinar. If you have any other questions, please contact Jason or myself. You will receive a follow-up email probably within about 24 to 48 hours with the link to the recording of today's webinar. But on behalf of Ekahau, I just want to thank everybody for joining, and thank you, Jason, for delivering this awesome presentation. And have a great rest of your day.
All right. Thank you for hosting. We'll talk to you soon.